Welcome you all, myself Swati Devkate, Department of Chemistry, Tuzaram Chatuchand College, Baramati. Let's start the today's topic, Shikimic acid pathway. So shikimic acid pathway is the secondary metabolite pathway. What are the secondary metabolite? These are generated or derived from the primary metabolites, and this shikimic acid pathway is a 7-step metabolic pathway and used by bacteria, fungi, algae and plants. It does not observed in humans or animals. It is not observed. Used for the biosynthesis of aromatic amino acids. Which are the different amino acids? They are, for example, phenylalanine, tryptophan and tyrosine. What are the precursor for this? Precursor are carbohydrates derived from glycolysis and pentose phosphate pathway. Let us see the mechanism. So, in mechanism, see phosphoenol pyruvate and D-erythrose 4-phosphate. So, we have seen that these are the precursors and derived from glycolysis and phosphate pathway. So, this is a simple aldol type condensation. So, aldol type condensation, here we are getting bond between this carbon and this carbon. So, it is forming a bond between these two. Again, in presence of, it is forming a DAHP, that is 3-deoxy-D-arabinoheptulozonic 7-phosphate, and it is next step, it is in presence of NAD+, that is oxidizing agent 3-hydroquinate synthase enzyme. It will help to remove the or minus POH, and it will form a bond, double bond with this. So, this forms a double bond with this here. Again, this double bond, it is also aldol type reaction, and here this carbon and this carbon will form a double bond. We can see a double bond between these two. Okay, so this is the structure of 3-dehydroquinic acid. So, 3-dehydroquinic acid in presence of 3-hydroquinase, it forms removal of, or it helps to remove the water molecule. From where it removes the water molecule? It removes the water molecule from here and forms the double bond over here. So, it forms the 3-dehydroshikimic acid. In presence of NADPH, we know that NAD plus is oxidizing agent and this is the reducing agent. In presence of shikimate dehydrogenase enzyme, it forms the shikimic acid. So, what it does, it reduces this double bond into CHOH, and this is the shikimic acid. So, shikimic acid, once it is formed in presence of ATP shikimate kinase, it forms the phosphate, here it removes the ADP. So, minus ADP, one of the phosphate group will be attached here. So, OH will be converted to OP, and in next reaction, again in presence of phosphoenol pyruvate shikimic acid, it forms the O alkylation. So, it forms the bond between oxygen and this carbon. So, we are looking here, see this oxygen and this carbon is forming bond here. So, in this step one intermediate is formed where oxygen and carbon bond is formed. Then minus HOP, it will give 5-enol pyruvyl shikimic acid. So, in next step what will form? This is EPSP, that is 5-enol pyruvyl shikimic acid. In last slide we have seen how it is formed. Then in presence of chorismate synthase, that is it will remove one of the water molecule, and how it will remove the mechanism I can show you. So, 1,4 elimination of HOP minus HOP. Here we can see that removal of HOP in presence of FMNH2 and chorismate synthase enzyme, we get the chorismic acid. So, in next step, chorismate mutase enzyme will help to form a rearrangement reaction where 1,3 rearrangement we can see. So, this is the mechanism in which bond is formed between this carbon and this carbon we can see. So, this is the rearrangement where 1,3 shifting is there. Then this is the prefenic acid in presence of prefenate dehydrogenase, it forms the or it removes the CO2 molecule minus CO2 and H2O. So, it will remove how this is the mechanism given where we will get the benzene ring, aromatic ring, and it is called phenylpyruvic acid. So, phenylpyruvic acid in presence of PLP, what is PLP? Pyridoxal phosphate, and it will help for transamination. Carbonyl group is converted to NH2. So, in this way, in presence of phenylpyruvate aminotransferase enzyme, phenylpyruvic acid is converted to L-phenylalanine. This is the aromatic compound that is secondary metabolite which is aromatic amino acid. So, this is the assignment on this topic where we can see that this is the chorismic acid. We have seen that how this chorismic acid is derived. This is shikimic acid and this is the chorismic acid. This is the chorismic acid and question is asked how chorismic acid is derived, how chorismic acid to phenylalanine, L-phenylalanine aromatic amino acid is formed. So, we just have seen that the biosynthesis of phenylalanine with the help of shikimic acid pathway. Again, second question is erythrose 4-phosphate and genesis to shikimic acid. What is the shikimic acid? We have seen that erythrose 4-phosphate. So, this is the erythrose 4-phosphate, and with this journey or this step we have synthesized that how it is synthesized biochemically the shikimic acid. So, this is the assignment. Thank you.